Right, this is csc264. Yeah, this is csc264. Web and mobile application development. So this subject will require you to do some tremendous work, because the thing is, the subject is 4 credit hours. The subject is easy to pass, provided that you submitted or you submit all your coursework. Right, there are 4 assessments altogether, which we will cover shortly. Now for this subject, we have got all of this to cover. Yeah, week 1, introduction to the internet. Week 2, introduction to HTML and multimedia on the web. Some of these are quite fairly easy. We may probably be able to continue and try to finish slightly early, so that you will have plenty of time to work on your bigger projects. But with this semester, you are going to submit your first assignment fairly early. Yeah, the first assignment is easy. You are going to develop, or you are going to create your own web page in which you are going to host it somewhere, and the requirement has been placed in the Google Classroom. All right. So these are the key things that we are going to cover. We'll have a test. We'll have a test in week number 7. For now, it is picked at week number 7. But then again, things may change a bit. We may have to move it a bit, but depending on the situation. But nevertheless, otherwise it is stuck at week number 7. Right. The mobile application is also a requirement, but the only problem here with this course is that it requires tremendous work in terms of, as much as it only has 4 assessments. Here we can see, here we can see only 4 assessments, but then again the work is more than 4. The first is to create a personal web page. The first is to create a personal web page that will carry 15%. Very, very important for you to submit. If you know how to work on a web page, I seriously recommend you to start working on your personal web page now. All right, because this is not difficult. You may have a look at the rubrics for marking in the assignment, in Google Classroom. For the assessment 2, it's a combination. We'll have a test which is scheduled at week number 7 that will carry 20% and another 5% from the proposal. Okay, altogether for assessment 2 is 25%. Now when you add them together, you'll get 40%. The group project. Now, what is the group project? The group project is when you work on group, sorry, not on group, in groups, to develop web application. To develop web application. Now, what is graded here? The web application will be graded based on what you have included. Again, the rubrics are available for you to see what will be counted for your marks. And finally, we have mobile application. What happens here is the mobile application is the extension to your web application. All right, when you develop your web application, the mobile application will be accessing the exact same database as your web application. So we are trying to expose to you how the world works. When you go out later, that's how the world works. Basically, nowadays, we are talking about a heterogeneous development. How is that? It's like this. Although we do not fully comply with that, but we try to expose you with as much as possible. Meaning to say, we create In this case, we create web. Let me change the color to black. We create a web application. Web application will connect to database. Correct?
Correct, sir.
Yes, this is a common practice. So, in CSC264, this is for CSC318. In CSC264, we create another one, mobile, to access the exact same database as the web app. Anything that you change using your mobile will be reflected in your web application as well. This is what we're trying to accomplish with CSC264. In real life, the case is slightly different. Yeah, we have database server, we have backend, we have front end. Backend will communicate with database server. Front end will communicate with the backend. Communication is using JSON. JSON is JavaScript object notation. Now the front end can be web, but we also can create yet another front end using mobile. And this mobile can be Android. And this is another front end, maybe using iOS. All of these also communicate with the back end. Also communication using JSON. So this is what we're doing, and the back end, front end, all of these things is called the infrastructure, or the development style is called MVC. So M for model, view, controller. So when we use MVC, it's likely that we are using OOP, as well as we are using REST API. But we're not going to go into this, and likely we're going to be using, if you were to do this, and likely we are also going to be using framework. Right? So we're not going to go up to this point. We'll only be using the one that I explained earlier. So we have database, web app, this include front end and back end, but we are going to use yet another extension here to create another front end on Android to communicate with our web app using JSON. on. Okay? Not as difficult. And of course, the infrastructure, we don't use MVC for now. Right? We don't use MVC for now. We use the standard one. So the changes that we try to implement is slightly small. It's nominal. Database. There you go. Any questions so far?
No, sir.
No, sir.
So, of course, as I mentioned, the subject is easy to pass, fairly, what shall I say?
Sir, nak tanya, sir.
Hmm,
Yang front end tu dia lain-lain Android dengan iOS tu? Asalnya?
yes, they are different.
Oh.
Right? They are different.
Oh.
Because we are developing not a web application, but a native application.
Oh.
Okay?
Yes, sir.
We're not going to go into iOS development. Why?
So we go to Android?
We only go to Android.
Oh, okay.
We're not going to go to iOS because iOS is expensive. Okay? In order for you to use iOS, you have to subscribe with Developer Prime, which will cost you $99 per year. Renewable, $99 per year. And not only that, you also need to have Mac. A Mac
Yeah,
device.
I think iOS.
Yes.
Too much cost.
iOS devices, you can only test on your iOS devices, not on everybody else. Whereas if you're using Android development, it's free. You can even test for free using any device that you want. And if you do not have any device per se, you can also use emulator.
Yeah.
Right?
Right.
So actually that is why we're only going to focus on Android development. In fact, with that Android development, if you want to publish to Play Store, it is also possible. Only that it will cost you. Yeah, if you want to publish your app, it is still possible. Only that it will cost you. But then again, the cost is not too expensive. Google charge you $25 for a lifetime.
Oh.
It is possible. Of course, if you plan to do that, then you have to get ready to go through strenuous red tapes before your application can be published. Right? But then, this is not the case. It's not too difficult anyway. It's just that those are the kind of things that that is expected out of you. So, for assessment, for the mobile application, since it's 40%, here you will also be graded on, you can see in the classroom, how will you be graded if you look at the project report guide, final report rubrics. There you go. Any rubrics, presentation rubrics, right? So these are the kind of things that you need to get familiarized with, because these are we give you marks based on these rubrics. So it's 5 o'clock. I think what we'll do is that we'll try to cover a bit of chapter 1 today, because chapter 1 is easy. So it's probably wise that we continue the lesson with chapter 1. They're planning to change the subject, but then again, it's not going to happen this semester. How many slides? Not too long. No, only 25 slides. Yes. Of course, I will go through fairly quickly with chapter 1. Right? I will go through fairly quickly with chapter 1 because this is not the part that you want to stress about, because apparently it only requires a bit of reading in order for you to answer the questions. It should be able to come out. So topics about this: introduction to the internet and the World Wide Web, HTML, client scripting, server-side scripting, current technologies, and those kind of things. Yeah. Brief history of the internet. The internet were computers basically started in the 40s, and they contain vacuum tubes. I'm sure you have studied about this as well in some other subject. Have you not?
Yeah.
What subject was it? csc159.
Yeah.
Now, in the 60s, computer science has shrunk, and the computer network is maintained by the universities. Yeah, of course, in the 60s, there weren't that many people that can afford that. And in fact, people do not have the capacity to study about that unless if they are super geek and they belong to the universities, and only they can do that. But otherwise, for normal home users, this is something that is out of reach. All right, computer network is used by the Department of Defense. Yeah, notice, yeah, the network initially started or used by the Department of Defense because they require another way of transmitting the information should the infrastructure fall down. They need to communicate. Suppose that the telephone line is down, they can communicate using the computer. That's why they introduced the computer network. In 1969, the Department of Defense created the first functioning internet that only had 4 network computers connecting UCLA, UC Santa Barbara, University of Utah, and Stanford Research Institute. The UCLA stands for, what does it stand for? The UC stands for University College. It's not even a proper university. It's University College. But of course, you said it maintained the name despite being extremely good with the research and stuff. So UCLA, Santa Barbara, Utah, and Stanford Research Institute. And they call that the ARPANET, the Advanced Research Project Agency Network. So what happened was that these 4 computers, as much as they could communicate with one another, should one of them is down, yeah, one of them broken, then the whole network is down. That was the problem. Of course, it was only the experiment. Yeah, they needed to work on that. But then again, that was the first step in computer networking. In 1969, the computers were able to communicate, but then again, the drawback or the problem were plenty and huge. The purpose of the creation was to maintain communication in the event of nuclear war. Yeah, again, it was meant for communication. In the 70s, the ARPANET gradually expanded. By 1984, it reached 1,000 hosts. Yeah. In the 80s, NFSNet was created in 1986, Connect Computers and Engineering Research. So initially it was called the ARPANET. In 1986, they created the NFSNet. When we talk about the ARPANET and NFSNet, this refers to the backbone. Yeah, this refers to the backbone. What backbone? Backbone of communication, so that these computers can communicate with each other. So in 1986 or so, there were 2 separate networks. One was meant for communication, and the other one was meant for research. Connect Computers and Engineering Research. Expanded rapidly. By 1990, it has 100,000 hosts. So it's a long way. Yeah, it was a long way from the 70s to the 90s. That's like 20 years. Expanded from 1,000 to 100,000 hosts. Then, of course, in the 90s, most of the computers were connected worldwide. They were no longer limited to the area of America, the United States of America. The NFSnet in the 90s, NFSnet replaced ARPANET altogether. The ARPANET sort of like was brought down, right? So NFSnet took over ARPANET. So if you look closely, if you remember, the ARPANET was meant for communication, NFSnet was meant for research, sharing, isn't it? So when the NFSnet, the sharing part, took over the communication part, this is why hackers tend to be able to snoop through, because initially the communication or the network, computer network, was created for sharing. When you want to share something, do you put restrictions? Obviously not, isn't it?
Yes, sir.
Yes, you want to share something with your friend, for example, or perhaps your group mate. All right, I only want to give you only 1/5 of this. You can only share this 1/5 part. No, you do not do that. When you come up with something with the food, you ask them, okay, if you want, you feel free to have it, because I share. Yeah, that's what happens. NFSnet was meant for sharing. You open everything, but then again, NFSnet has also expanded so big that people want to use that for many different purposes. Yeah, when people wanted to use that for many different purposes, of course, security has got to take place somewhere. This is why they come up with all the new things that say that they have inserted into the NFSnet to ensure certain degree of security is in place. In 1992, the World Wide Web appeared. It was created by Tim Berners-Lee, and um, if you're wondering, that Tim Berners-Lee is still alive here today. When we talk about history, more than likely we would think that those people are already away, but not in the case of computing, because most of the people who created something big are still alive. So Tim Berners-Lee is currently spearheading the W3 school, if I'm not mistaken. So he maintains the World Wide Web Foundation. The Internet is a global interconnected computer networks that use the standardized Internet Protocol Suite, the TCP/IP. Yeah. Initially, there were many different styles of communication. We had token ring, we had BNC, but generally nowadays most people opt for TCP/IP because TCP/IP is the de facto standard nowadays. Yeah, that's the thing. So what is TCP/IP? We are going to go into detail in a bit later. It is a network of networks that consists of millions of private and public, academic, business, and government networks of local to global scope that are linked by copper wires, fiber optic cables, wireless connections, and other technologies. What other technologies you can think of? We have copper wires. What are example of copper wires? Example of copper wires. The one that most universities, or if you are connected using cables, then of course you are using the copper wire. Yeah, the Cat5, Cat6, those are copper. Again, if you're using BNC, that's also using copper. Fiber optic cables nowadays, it's very common, isn't it? Fiber optic cables. In fact, I'm using also the fiber optic, although previously I was using the copper, yeah, using telephone lines. But now, luckily, they have expanded the coverage to unify, which I could subscribe. Wireless connection. Of course, wireless connection, example includes Wi-Fi, right? Wi-Fi is a short form, right? What does it stand for, Wi-Fi?
I don't know, sir.
Anyone?
Wireless local area network.
Wi-Fi.
Wi-Fi.
Wi-Fi. There's no local. There's no L. Wi-Fi.
That's LAN, local area network.
That's correct. There. That's LAN. This is Wi-Fi. Wireless fidelity. Okay.
Oh,
Wi-Fi stands for wireless fidelity.
wireless
What
fidelity.
other wireless communication that you can think of besides
Bluetooth,
Wi-Fi?
sir.
Bluetooth. Correct. Yes. Bluetooth. Anything else? That satellite
NFC.
communication. Satellite communication is also made possible nowadays communications. Although the cost is exaggerated, it's massive, but then again, it's available for general public to use. Yeah, wireless satellite communication, and I don't know whether you have experienced this or not, but all phones generally communicated using infrared.
Infrared.
Yes, infrared is also a form of wireless communication. You could connect to a modem using infrared, but
So, what kind of device use infrared?
the easiest device that you can think of is of course the remote for your TV.
Oh,
Okay, of course I can explain more in depth about infrared communication, but then again it requires quite a bit of um, technicality. So yes, that is wireless communication using remote to communicate with the device. Although back in those days, if you wanted to transfer your files from one phone to another, we could connect them using IR, infrared. Now move along. The internet network is a big network. This is a picture of the internet network. We have backbone ISP. Backbone ISP is a large ISP. We have regional ISP. Yeah, regional ISP, for example, here in Malaysia, we have Maxis, we have TM. Local ISP, the smaller one. Yeah, sometimes the regional outsource to local ISP. Those are the kind of things. Sometimes nowadays they are more interconnected than we can think of. Right? Why need for multi-satellite? Because satellite can only communicate to a certain degree of space. Yeah, if you notice that satellite, in order to communicate with the rest of the world, is not even possible. Okay, take for example, let me suppose that this is a sphere and we have satellite. Satellite can only communicate the beam covering from here to here, isn't it? Yeah, covering from here to here. This is
yes, sir.
satellite. So there are plenty of satellites up here. We have another satellite here, satellite here, satellite here. So what happens if you want to beam it somewhere from to here to this place? Then it will have to amplify the signal back to the satellite, post again to another one, amplify again to another satellite, amplify again, then only it can receive the signal.
Oh, so that satellite is reflect.
Yes, they need reflector because satellite can only cover a certain degree of angle for
Oh,
communication, right? Satellite, the most, uh, there are two more, no, hold on, three for communication. It's called, I can't remember what's the protocol for satellite communication. Uh, I can't remember. Honestly, I can't remember. That low aperture. was it narrow aperture, something like that. I can't remember, honestly. But the one that communicates like Astro that uses what is it? That's KU band. The one that communicates even greater distance is called the C band. Yeah. So C band can cover up to here, for example. KU band can target even smaller area. The other one, the one that I mentioned for satellite communication, target even smaller area. So even using the same satellite, depending on the protocol that it uses, you can target only certain degree of angles that user can access it. So that's about satellite communication.
Hmm.
Move along. Question now.
Move along, sir.
Now, the fast layer of networking. Yeah, although under general condition, we use 7 layers, but for the purpose of this course, they only try to focus on the fast layers. What are the 7 layers? 7 layers referring to the OSI model. If you remember, you have covered about OSI model, don't you? Have you heard of the term OSI model?
No, sir.
Honestly,
Yeah.
that was already covered in ITT 300. The 7 layers of OSI model.
I forgot, sir.
Huh?
I forgot.
Ah, the thing is, if you are planning to stick with CS or computing, those are the kind of things that is expected out of you. So if you have forgotten about it, it might be a good idea for you to revise it a bit. Yeah, revise it a bit because they are applicable and they are sort of like even if you're working later on, people would expect you to know about this. So
Okay.
of course, the lowest one is called the physical layer. Yeah, the physical layer referring to the how your computer is connected. For example, using coaxial cable, copper wire, either Bluetooth radio communication. Those are the kind of things referring to the physical layer. On top of the physical layer, it's called the network interface layer. What is the network interface layer? It's your network card. Yeah, network card. How or what device do you use to communicate? Referring to the real network. Next up, for example, here it says Ethernet or PPP. Ethernet is referring to the communication devices using mostly cables generally, yeah, mostly cables, but they have extended Ethernet to cover for Wi-Fi as well. That PPP, which is short for point-to-point protocol, is a communication standard to communicate with different computers. For example, you want to connect to ISP, you use PPP, point-to-point protocol. Unify is using PPP. Although in terms of Unify, they would say that they use PPPoA or PPPoE. Alright? Next up is the internetwork layer, the IP layer. This is where the IP is located. IP referring to the address of a computer. Ethernet has got an address as well, but the IP is yet another address. Yeah, yet another address. So generally, for a computer to communicate, there are a few sets of addresses that computer carries. Moving along on the top layer is called the transport layer. In the transport layer, we have TCP and UDP. What is TCP? It's a standard. Yeah, when you send information, a large information, computer network will not be able to access those data. What they do is that TCP will capture those data, break down into smaller pieces, and send it down to the IP layer, where IP attach itself into the packet, move downwards to the network interface layer, send it across another computer using the physical layer. That's how it works. So TCP, of course, Transmission Control Protocol. UDP is User Datagram Protocol. What is it for? The same thing for TCP, but then again with TCP, it's even more secure, rigid, because TCP can allow for a request. Request meaning to say if one of the packets does not reach the destination, then the client can request for the server to resend the packet. And once everything is in place, you can move up to the next layer, to the topmost layer called the application layer, where we have the HTTP, FTP, Telnet. Those are all the topmost application layer. And these are the communication that we normally use. So the packets will have to travel through downwards and upwards according to the situation. We'll cover more about that anyway. Now TCP/IP is a protocol that is used to enable communication on the internet. Yeah. To enable communication on the internet. Coordinate the addresses of all the computers on the internet and the away resources that passes on. The protocol that is used to enable communication. Hold on. Oh. The internet is mainly built on client and server technology. In this concept, we have a number of computers that houses information that users can access via their computers. And the computers that house the information is known as server, while the user's PC that access the server's information is known as client. Alright, so when we work on PHP application or web application later on, you may come across this term, right? When you work on your personal web page, it doesn't matter whether you have the server or not, because you will be developing page using HTML. When using HTML, it's the task of the browser to render the output for you. But when it comes to scripting language, PHP scripting language requires a server to translate. If you've only passed that to your web browser, it will not be able to display or run it. It will merely output that as a text file. So this is why we need server and client. So for example, when you're working on PHP, you will be required to install a server into your computer so that it will be able to render the page for you correctly. The internet carries a vast array of information resources and services, most notably the interlinked hypertext document of the World Wide Web and the infrastructure to support electronic mail, in addition to popular services such as online chat, file transfer and file sharing, online gaming, and voice over internet protocol, person-to-person communication via voice and video call. So the internet is huge. It's a collection of all of these services. Yeah, but not limited to this, of course. There are hundreds, even thousands of services available. The World Wide Web, commonly abbreviated as the web, is a system of interlinked hypertext document accessed via the internet. And with a web browser, one can view web pages that may contain text, images, videos, and other multimedia and navigation between them using hyperlinks.